everyone, welcome back to my channel. In this video, we are going to study about center of curvature and circle of curvature. Here is a definition of center of curvature. Center of curvature at the point P of x, y to the given curve is the point C of x bar, y bar which lies in the direction of inward normal drawn at the point P of x, y which lies at a distance of rho. This is a definition of center of curvature. Let us understand it geometrically. This is x-axis and this is y-axis. Consider any curve in xy plane. Let P of x, y be any point on the curve. So the definition of center of curvature says at the point P of x, y to the given curve is the point C of x bar, y bar which lies in the direction of inward normal drawn at the point of P of x, y. The center of curvature is nothing but C of x bar, y bar which lies in the direction of inward normal to the point P. This is a point P of x, y. To draw the inward normal to the point P of x, y, we must require tangent. So this is a tangent at the point P of x, y. Now we all know that the normal vector is drawn perpendicular to the tangent P of x, y. So this is our normal vector drawn in the direction of inward to the point P of x, y. Hence, we can conclude that this point is nothing but C of x bar, y bar. This is our center of curvature. So, what is the definition of center of curvature says? At the point P of x, y to the given curve, the center of curvature is nothing but C of x bar, y bar, which lies in the direction of inward normal drawn at the point P of x, y, which lies at a distance of rho. The distance from C of x bar, y bar to the P of x, y is nothing but our rho, where rho is nothing but radius of curvature. So this is a definition of center of curvature. Also we have an equation of a circle whose center is C of x bar, y bar and the radius of curvature is rho is nothing but a circle of curvature. After obtaining the definition of center of curvature, and the equation which contains the center of curvature C of x bar, y bar and the radius of curvature rho is called as circle of curvature. It is denoted by x minus x bar whole square plus y minus y bar whole square which is equal to rho square, where x bar is nothing but x minus y1 into 1 plus y1 square by y2 and y bar is nothing but y plus 1 plus y1 square by y2, where y1 and y2 are nothing but first order and second order derivative of y with respect to x. So this is a formula to find the coordinates of center of curvature. That is C of x bar, y bar is a formula to find the coordinates of center of curvature. We shall see some problems so that you can understand in a better way. Here is the first problem. Find the coordinates of center of curvature at the point at square, 2at on the parabola y square which is equal to 4ax. The coordinates of center of curvature is given by the formula x bar which is equal to x minus y1 into 1 plus y1 square by y2 and y bar which is equal to y plus 1 plus y1 square by y2. Here what's the first step? We have to take the given curve, that is y square is equal to 4ax. Then we have to find y1 and y2 for this and we have to substitute in the formula of x bar and y bar. First take the given curve, that is y square which is equal to 4ax. To obtain y1, we have to differentiate this equation with respect to x. Differentiating y square with respect to x, we get 2y into differentiation of y is dy by dx which is equal to, here 4a is constant, take as it is, into differentiation of x is 1. Here 2 gets cancelled, hence we obtain y into dy by dx which is equal to 2a. We can write in the place of dy by dx, that is y1, which implies y1 which is equal to 2a divided by y. If we take y to the right hand side, that becomes 2a by y. That is our y1. Here in the given problem, they have asked to find the coordinates of center of curvature at the point at square and 2at. This is our x coordinate and this is our y coordinate. Hence, at at square, 2at, y1 becomes, in the place of y, we have to substitute as 2at. Hence, we get 2a divided by 2at. Here 2a gets cancelled. Hence, we get y1 value as 1 by t. This is our y1. Again, we have to differentiate this equation with respect to x. We get y2 as, here 2a is constant, take as it is, into 1 by y differentiation is minus 1 by y square into, again we have to differentiate y with respect to x, we get y1. At the point at square, 2at, the y2 becomes, substitute x value as 8t square, here no x value, and substitute y value as 2at here. We get 2a into minus 1 by, in the place of y we have to substitute as 2at whole square into, we know that y1 value is 1 by t, substitute as it is. Here 2a and 2a gets cancelled, remaining will be minus 1 by, here 2a gets cancelled, that is 2a into t square into t is t cube, that becomes minus 1 by 2a t cube. This is our y2. Now after finding y1 as 1 by t and y2 as minus 1 by 2a t cube, we have to substitute in the formula of x bar and y bar. Now substitute x value as at square, y1 as 1 by t and y2 as minus 1 by 2a t cube. In x bar formula we get x bar which is equal to at square minus y1 is 1 by t into 1 plus y1 square is 1 by t square divided by y2 is minus 1 by 2a t cube. If we multiply 1 by t inside the bracket and simplify, we get at square minus 1 by t into 1 is 1 by t plus 1 by t into 1 by t square is 1 by t cube divided by minus 1 by 2a t cube. Here minus into minus we can take it as plus, hence we get x bar value as at square plus, if we take 2a t cube to the numerator, that becomes 2a t cube into, take t cube as LCM and simplify, we get t square plus 1 divided by t cube. Here t cube gets cancelled, we get at square plus 2at square plus 2a into 1 is 2a. Here at square plus 2at square is 3at square plus 2a. This is our x bar. Similarly, we have to find y bar as y bar which is equal to y plus 1 plus y1 square by y2. Here substitute y as 2at and y1 as 1 by t and y2 as minus 1 by 2at cube. We get y bar which is equal to 2at plus 1 by t square divided by y2 is minus 1 by 2at cube. Taking LCM and substitute, we get 2at, here plus into minus minus, we take 2at cube to the numerator, that becomes 2at cube into, here 1 plus 1 by t square, if we take t square to this side, we get t square plus 1 by t square. Here t square gets cancelled, that becomes 2at minus, here in the outside the bracket we have 2at into t square is 2at cube minus to plus minus 2at. Here plus 2at minus 2at gets cancelled, hence we get y bar as minus 2at cube. Here x bar as 3at square plus 2a and y bar is minus 2at cube. Hence we get the center of curvature of a parabola at at square comma 2at is 3at square plus 2a comma minus 2at cube. This is a value of center of curvature of parabola at the point at square and 2at. This completes the problem. Here is the next problem. Find the coordinates of center of curvature at the point 3 by 2, 3 by 2 of the curve x cube plus y cube which is equal to 3xy. We must all remember the formula to find the coordinates of center of curvature. Here what's the first step? We have to find y1 and y2. After finding y1 and y2, we have to substitute in the formula of coordinates of center of curvature, that is given by x bar which is equal to x minus y1 into 1 plus y1 square divided by y2 and y bar which is equal to y plus 1 plus y1 square by y2. Here differentiating the equation with respect to x, we get differentiation of x cube is 3x square plus differentiation of y cube is 3y square into differentiation of y with respect to x is y1 which is equal to 3 into, here x and y both are function, so apply product rule over here. We get first function as x into differentiation of y is y1 plus second function is y into differentiation of x is 1. Here 3 gets cancelled in both left hand side and right hand side. Rearranging the term, we get y square minus x into y1 which is equal to y minus x square. If we take x square to the right hand side and x to the left hand side, that becomes y square minus x into y1 which is equal to y minus x square. Now we get y1 as y minus x square divided by y square minus x. This is our y1. But in the given problem, they have asked to find the coordinates of center of curvature at the point 3 by 2, 3 by 2. Here x value is 3 by 2 and y value is 3 by 2. Now at the point 3 by 2, 3 by 2, y1 becomes, substitute y as 3 by 2 and x as 3 by 2, that is 3 by 2 minus x square is 3 by 2 whole square, that is 9 by 4 divided by y square is 3 by 2 whole square, that is 9 by 4 minus x is 3 by 2. Now take LCM and simplify, we get, here take 8 as LCM, we get 12 minus 18 divided by Here also take 8 as LCM, that becomes 18 minus 12. Here 8 gets cancelled, 12 minus 18 divided by 18 minus 12 we get as minus 1. Hence we get y1 value as minus 1. Also we have to find y2. For that, differentiate this equation again with respect to x. We get y2 as numerator divided by denominator, both are functions, so we have to apply quotient rule over here. Hence we get denominator into d by dx of numerator, that is numerator is nothing but y minus x squared, that is differentiation of y minus x squared is y1 minus 2x minus numerator, that is y minus x squared into d by dx of denominator, that is 2y into differentiation of y with respect to x is y1 minus differentiation of x is 1 divided by denominator whole square, that is y square minus x whole square. This is our y2. At 3 by 2, 3 by 2, substituting x value as y 3 by 2 and y value as 3 by 2, we get 9 by 4 minus, this is y square is 9 by 4 minus x is 3 by 2 into y1 value is minus 1 minus 2 into x value is 3 by 2 minus y value is 3 by 2 minus x square is 9 by 4 into 2 into y value is 3 by 2 into y1 is minus 1 minus 1 divided by y square is 9 by 4 minus x is 3 by 2 whole square. Substitute the value carefully and simplify. Here we get, in the numerator we have 9 by 4 minus 3 by 2, take LCM and simplify, we get as 3 by 4 into here 2 gets cancelled, minus 1 minus 3 is minus 4. Here we have minus, here 3 by 2 minus 9 by 4 is nothing but, we get as minus 3 by 4, hence we get minus into minus plus 3 by 4 into, here 2 gets cancelled, 3 minus into minus, 2 gets cancelled, 3 into minus 1 is minus 3, minus 1 is minus 4 divided by 9 by 4 minus 3 by 2 whole square is 3 by 4 whole square. Here 4 gets cancelled, here also 4 gets cancelled. Simplify, we get y2 value as minus 32 divided by 3. Here we get y1 value as minus 1 and y2 value as minus 32 by 3. After finding y1 and y2, we have to find x bar, which is equal to x minus y1 into 1 plus y1 square divided by y2. Here substitute y1 as minus 1 and y2 as minus 32 by 3 and x as 3 by 2. We get x bar, which is equal to 3 by 2 minus y1 is minus 1, y1 square is minus 1 whole square divided by y2 is minus 32 divided by 3. That becomes 3 by 2 minus, here minus 1 into 1 plus 1 is 2. Hence we get, in the numerator, if we take 3 to the numerator, that becomes minus 2 into 3 is minus 6 divided by minus 32. Here minus gets cancelled. Here we get 3 by 2 minus 3 by 16. Here 2 3s are 2 16s. Hence we get 3 by 2 minus 3 by 16. Simplify the term, we get x bar value as 21 divided by 16. Similarly, we have to find y bar, which is equal to y plus 1 plus y1 square divided by y2. Here substitute y1 as minus 1, y2 as minus 32 by 3 and y as 3 by 2. We get 3 by 2 plus 1 plus y1 square is minus 1 whole square divided by y2 is minus 32 divided by 3. We take 3 to the numerator and simplify, we get 3 by 2. Here plus into minus, minus, we get minus into 1 plus 1 is 2, 2 into 3 is 6, that is 6 divided by 32. Hence to take LCM as 16 and simplify, we get y bar as 21 divided by 16. Hence we get the center of curvature at the point 3 by 2, 3 by 2 as 21 by 16, 21 by 16. This is a center of curvature value. These are all some problems related to how to find the coordinates of center of curvature. Till here we studied about center of curvature, circle of curvature and the problems related to this. In the next video, we study about evolutes and involutes of the curve.